Right, if you watched my last video on making this 24 volt handheld compound slide drive tool or power feed tool, you'll have seen me making up this bracket here to hold the on-off button. And today I'm going to show how easy it is to actually make this brass drive piece up and wire the actual unit up. And I'd just like to say that you can actually make these drives up out of PVC, aluminium, steel, or whatever you like really. I like to use brass because it makes it look a high quality tool. So to start with, I have a piece of 22mm diameter brass bar which I got off of eBay, and I'm going to part off a piece which is about 58mm long. And to part it off, I'm going to use this 2mm wide groove tool. So that one's a nice tight fit on that shaft there, which is about 3/14/8 or 3/15 thou, and I use the 5/16 drill because drills tend to cut oversize, so I didn't use one to size. I used the 5/16, which is about 0.312, and that comes out spot on. Failing that, you could actually cut it undersize and bore it out with a small boring bar to size. But whenever you're going to fit a component like this onto a shaft, you want it as close fitting as possible. If you're new to engineering, this is one of the most important books you should have in the workshop. It's called the Zeus book, and it has data charts, reference tables for drawing office, toolroom and workshop. When you open the first page there, it gives all the standard drill sizes and decimal equivalents, so you can actually choose the smaller pilot drill to go down first, and then you can actually choose a drill which is a few thou undersized to the finished size like I showed there, and when it drills down through after the pilot drill, it will come out spot on size like this one. So now I'm going to measure up the handle on the end of my compound slide on the Myford ML7, the ball part on the centre there, and my next bore on the component, or the front bore on the component, has obviously got to clear that ball diameter. Incidentally, I've just got this 0 to 25mm digital micrometer from Banggood, and it's one of the best 0 to 25mm micrometers I've seen and used, and that's because the ratchet thimble is here rather than being on the top. You have a nice feel to it. You can actually use it with one hand, and using the ratchet like that will make sure that you get exactly the same reading every time, because you know that you're not over tightening it and getting a false reading. So I think it's, like I say, one of the best ones I've seen and used. And I actually work in inches, and it has inches or millimeters, and it runs on a CR1632 battery, which is easy to get hold of, and there's a data port here on the back as well. Plus it's an absolute micrometer, so when you actually turn it off, when you turn it back on again, it will remember the exact reading that it was turned off at, and you can then actually turn it off and move the micrometer, and it'll take into consideration that movement and come on with the exact size. And I do make mine quite a bit bigger than the compound slide handle. I'm using an 18mm drill here because I drill it out and bore it out so that it will fit my cross slide handle as well. And then to make the adapter look really nice, I always do a couple of decorative grooves. I then put the adapter in soft jaws in the vise here, and I use a small file first. This is a chainsaw file. They're very good, nice and sharp and great to use. And using a small one first, it makes it easy to actually get it dead centre. And I file the back rim first, just to get the centre, and then bring the file down to the other side. I then use a coarse round file and file down to the back face of the bore. Or just short of the back face of the bore. And obviously the slot has to be just wide enough to go over whatever handle you're putting it onto. Next I put the adapter in this vise here, and this vise has a V on one side, so it sits in that V and then it's nice and parallel. And I'm going to be drilling now for the core diameter for a 6mm thread. And when I do drilling on something like this, if there's a slot, I like to actually get the thread in line with the slot, or the opposite way. It just makes it look nice and tidy. And I could have used my lathe tool post drill to do this operation, but because I'm only doing a one-off component, it's not worth actually setting up. So again, if you're new to engineering and lathe work, this is where you would consult your Zeus book again, and you'd look up for metric threads, isometric coarse threads, and I'm going to be using a 6mm thread. So then I look up the core diameter for that thread, and the tapping drill over here on this side is a 5mm drill. And I always like to drill with a smaller drill first, obviously so that the core diameter drill drills to size. So I shall drill through with a 4mm drill and then the 5mm drill. And whenever you're doing a component like this, always when you pick up the core drill, make sure you check the size and even measure it with the micrometer to check that it is the right size. So then I use the 6mm tap and I put that one in the drill. You do this if you're not used to getting a tap nice and square in a piece of work. You know that this is nice and parallel and square in the vise and jaws here. And this is a method you can actually use. to actually get the thread nice and square, you never start the drill up with this tap in the chuck or anything. You bring it down by hand, and you can turn the tap or turn the drill by hand to actually start the thread off like that, and hold it down, or hold it down like that, undo the chuck, and then let the drill come up like that, or the drill chuck come up, and leave the tap in the work. You know it's nice and square. So then I put the vise into my bench vise, and I use an ordinary tap wrench to finish off. And these are all little tricks you can do, especially if you're new to engineering. You'll get a nice thread that's square to the work without any problems at all, and it makes things so much better. And then I just deburr the thread with this one. And then to finish off, I use this excellent little buffing tool which I got from Banggood. It's a really super little tool, and I use this buffing compound here. It's an abrasive compound, and you can get it in various different grits. I think there's 3 different grits. This is 180 grit, and you can get this on eBay. I'll put a link below where you can get it, because it's the best buffing compound you can get for deburring, polishing or whatever. The reason it's the best is because it's a water-based one. Most of them these days are grease-based, and you can actually use this one to buff up like brass, like I showed earlier in the other video when I did the soldering. You can buff the brass up using this one without having to clean the brass afterwards to do the soldering, because it doesn't leave any grease. And when you get this one, just make sure you keep it in a cool place, because I've actually left it out in the sun before and it actually does melt. Also, cover it up in a resealable plastic bag or something, or just cover it over with cling film so that it doesn't dry out on the end. If it does dry out a bit, put it into a container with some water in the bottom and leave it for a few days, and it should soften up again. And it is really best to deburr these really with a Swiss file before you put it on this one, because it saves the buffing compound and also saves the wheel. When you apply the buffing compound, just leave it for about a minute just to harden up before using the wheel. And then to finish it off and make it look really nice, I give it a spray of red paint. It's acrylic based one, like that. Just make sure the grooves are filled. So you can see there the grooves are nicely filled, and I've screwed the actual grub screw further down so it's below the surface. Then I let it dry. It dries within probably about 15 minutes, and then I hold it in the lathe and use some medium wet or dry or emery and carefully polish off the diameter without allowing the wet or dry to go in the grooves, and that'll leave two nice groove red lines. So you want to avoid taking out the paint in the groove there. And that's the job finished. Right, to wire it up, I bought these 5.5 jack plug sockets on Banggood. You can get a pair of them for about £1, I think. And obviously this one's going to go on the actual drive, and this one will be used later when I get the other components to show you how I do the transformer and the other wiring for this to plug into. So I'm not going to actually show any soldering today. I'm going to just show you the straightforward connections and how easy it is to wire up. I actually cut this one down a bit. And then separate the wires a bit there like that. And obviously strip them. And then I've loosened the bracket off a bit on the screws on the side there, and that one obviously tucks up under the bracket like that and goes down the front of the bracket in front of the next screw, and push that one down. Like that. So then I strip the motor wires a bit, and again these feed up through the bracket at the back here. You might have to loosen the screw off a bit more, but that one seems to be going through alright. And I have it going under the motor like that, pull it up, and when you push the wires down on the front here, I have them just behind the 4mm screw on that side, so they come down behind that screw, so it looks like that. The plug wires at the front, in front of that screw, and the motor wires just behind the front screw. And that's just to keep the cables tidy and out of the way. Then you take the singular red wire and solder it onto one of the terminals on the momentary button there. And then you take the red wire from the motor and solder that on the other terminal. So it's the two red wires to the momentary switch. And then I take the red black wire from the socket and I put a piece of the right size heat shrink over that wire, and obviously slide that one right the way up. You might have to cut that down a bit. And then I take the black wire from the motor and connect those two together, wind those two together like that, solder them up, and then fold it down over the thin wire like that, and bring the heat shrink down over that join and heat that up to seal it in and keep it nice and neat. So I haven't actually soldered this one yet, I've just put it on now. The two red wires to the momentary button there, and then the black and red wire soldered together there, and then the heat shrink shrunk onto that. And if you want to, you can actually put this piece down here like that when it's all done, and put a bit of gaffer tape over there or something like that, or you could make just a little bracket there from that screw hole just to hold that down. A nice little plastic bracket, but you don't want anything sticking out there too far, because it's actually nice to hold just as it is. And the socket there comes down at the back and is out the way, and it's as easy as that to make up. So I'm just waiting for some other electronic components to come through, and then I'll show you the finishing video to this one. It's all very straightforward. It's basically a transformer and that other component wired together, and this one plugged into it, as you saw in the first video. And it is actually a great little tool, as you would have seen in that first video.